June 26, 12:30. I've decided to test the system with three aircons. So the house is running, this inverter is running the house right now. So the load to the house is 200 watts or 200 VA. It tells me that there's hardly any inductive load, motors in other words. So I'm going to heavily load it with several aircons and see what it does. Maybe three aircons. So right now, because it's loading, it takes some power from the PV. The PV right now is at 35 volts. And because the load is not that heavy, it's 15%, and there's enough charge, as you can see, 27.5. So this system, like I said, it takes solar panel. If there's capacity, then it would add into the add with the battery and then drive the house. So if there's enough capacity at the solar panel, then most of the energy comes from the solar panel. So that's how it works. So I'm going to turn on the first aircon in a moment. So Paul just turned on the aircon. I recalculated or calculated out what is the horsepower for these aircon. They are 0.6 HP. So that's what it is. So the load now is at 27%. And there's no current going into the battery because it's sharing the load between solar panel and the battery. So this is the system. Okay, and the PV voltage is at 25. So Paul will be turning on the load, the other aircon, and so now the load now with two aircon is at 1.36 kVA. What it's doing, and the load is at 50% power capacity. So this thing will provide 3000 kVA. It's now using up one half of 3000, so it's 15,000 kVA. So there's another 15 kVA available for other loads. So the third aircon will be on in a moment, shortly, and it should go up to 1.6 kilowatts. So there's a message here telling me the overload, and the overload is brief because it needs to warn people. Okay, there's the overload. Now it is at 1.8. So it is now at 2 kVA. So there's one more 1000 kVA left. And the load is at 73%. So let's see here. With 2 kVA, can't remember. So 3000 kVA gives us 48 minutes. So with 2000 kVA, it's slightly over an hour. So as you can see, the battery is now at the low bar. Okay. Really, if there's a lot of solar capacity, it would hardly touch the battery. But in this case, there's little solar capacity. So this system can sustain 3 aircon, and the aircon is 0.6 HP. So, and there's very little left capacity. I mean, there's let's say 80%, so there's 20% capacity. So you don't really want to do this, but for the sake of this test that I wanted to do, then this demonstrate the capability of this inverter and battery. So it would run this for a couple of hours, and that's good job. This is really a good test. So this is now only running one aircon. So I'm doing a test for tomorrow. So I'm gonna let it discharge and have this running for 4 hours. It'll be fully discharged. It's 7 o'clock. So this machine has been running since 12:30. 12:30? Yeah, I think 12:30 or 1:30. I can't remember. So it's down to 2 bars. Actually, it's 22.6. So this is the steady state of the house with various load on 570 VA. So initially I had the aircon running for an hour. It has some capacity left. Now this load is just factor in 2400 watts, and out of the 2400 watts is just taking 20% of that. So that's what it means. So tomorrow I will be doing some tests with respect to current going into the battery, so charging in other words. So quite frankly, I have a lot of respect with this inverter and battery capacity of 150 amp hour. I would have thought it would have died or depleted. Nelia and I went to Cauayan, and I thought this is a good test to see what happens to the capacity. It has a lot of life left, so it's 2 bars. Probably another 4 hours. I'm just guessing. I don't know. So with a light load and no aircon running, fridge are running, lights, fans, that sort of thing. So that's this inverter. It's really good. Quite frankly, I would recommend it for household item. The thing that I want to do though is higher power rating, like 5 kilowatts. Thanks for watching.